Hi everyone, good morning, good afternoon, good evening from wherever you are joining us. We are back again with another session, and this time we have Anshu Bathla with us. He's going to be talking about security with Open Policy Agent or shift left security with Open Policy Agent. When we talk about Open Policy Agent, this is a very interesting topic and not very talked about. And at OWASP stage, we wanted to have this kind of a topic, and especially I wanted to understand more around how we can have policy as a code. So let's get started, Anshu. Welcome on the stage of OWASP AppSec Days India 2024. And now the stage is all yours. You can talk about yourself. Then you can talk us through the presentation that you have today.
Thank you, Vanna. Hello, everyone. Good morning, good afternoon, good evening to everyone from all around the world. So, my name is Anshu Bathla, and welcome to OWASP AppSec Days India. Today, I'm going to present about shift left security with Open Policy Agent. In the short form, we call it as an OPA. The objective of this presentation is to understand how we can leverage OPA to secure our infrastructure in a scalable way for cloud native applications with shifting left strategy. Shifting left term is quite famous from last few years. So what does it mean is conducting your testing sooner in the development phase in SDLC. So as an outcome, you will get the secure product at the end. We understand from SDLC, software development lifecycle, that in design phase we gather all the functional and security requirements for our developer. But how to enforce those security requirements? There should be a way. So we are going to do it with OPA. Before moving forward, I want to introduce myself. So my name is Anshu. I'm based out of Gurgaon, India. So I've been to cybersecurity industry from last 14 years. So I'm into different security domain from the beginning of my career. I've been into security operations, device management, and then later part of my career with some architecture and consultancy role. So in my free time, I love to do gardening and cooking. So I mentioned my LinkedIn and x.com link here. I'm happy to connect with you guys. So I want to go through the agenda which we are going to cover in this presentation. So I'm going to explain you what is policy as code, how we can leverage it to enforce and secure our application, what is OPA, Open Policy Agent, and how it can be used in a scalable way to secure your application. Then we'll talk about Rego. It's a language, so I'll explain you what it is, how we can write it, and how we can use it. Then there'll be some benefits I'll be talking about of using OPA. Then there'll be different use cases I'll be talking about where you can apply OPA policy engine to secure your environment. It could be infrastructure provisioning, your application API gateway security, or it may be your Kubernetes cluster you want to secure. So OPA fits almost in all the environment. Then I'll be talking about how we can integrating it with the CI/CD environment. You might be running using VCS system, GitHub, Jenkins in your environment. So I'll take one example and explain you. And then finally, I'll give you demo. So how to use OPA in a practical way. So before moving forward, the takeaway from this presentation would be you will be able to understand what OPA is, how it works, and then you will also get the idea how you can leverage this and implement in your environment. Before moving forward, I want to show you two pictures. So from gate to guardrails, and I'll explain you why I'm using these pictures here. So on the left side, you are seeing there is a gate. So once you get an entry in the gate, you will enter in a premises, and by default you will have access to all the amenities whatever is available uh, in that area, maybe swimming pool or maybe badminton court or some buildings. You would have access to it once you enter the gate. There is nobody there to stopping you. Now if you look at the right picture, so there is a road going, and on both side of the roads there are guardrails. So what it does, it doesn't allow you to go left or right. It giving you a path to go to your destination, right? So that is the idea here. So when we talk about OPA, it provides the policies, set of policies, that these are the actions allowed. You cannot go outside that. This is the path you need to follow. So that is the approach we are going to use with OPA today. Let's move forward. So before diving deep into the OPA, I want to explain you what is policy as code. What are policies, first of all? So policies are one key way that organizations ensure the software is of high quality and secure, easy to use, and as per their standards. And how you will make sure you will manually review your softwares to make sure that your software is compliant with the policies which you have defined. But this process is time consuming and impossible to scale. Think of, you will have multiple applications and you are growing. So how do you do those manual reviews every time and whenever there's a new application you are launching? So there is a solution here, policy as code. So how policy as code helps here, that it automates the decision making process by codifying and enforcing policies. It can be used to automate validation procedure to control and manage infrastructure. So with policy as code, you can scale easily by applying this validation process as part of your maybe CI/CD pipeline. So you don't need to worry about how many applications you have, how large code you have. You just need to run policy as code, which is set of policies against your application code, and then it will tell you the decision, okay, it is compliant or not. So policy, when we talk about policy as code, we understand now that how it works. It automate the process. But what does it need to make that making process automate? So it has basically three components. One is policy, the other one is data, and third is query input. So policy is a code that models the decision making process used to determine whether a software release is compliant or not. This includes a set of conditions around application quality, performance, ease of use, and more. So you will define your standard in the policy. Okay, this is my standard. I need my application to follow these standards. So that is the policy you write. So codifying it, as I mentioned. And then data. Data is your code which you want to check against your policy. It could be Kubernetes configuration. It could be your cloud infrastructure configuration. It could be your application API information which you want to enforce. And then query inputs. Query inputs is a process of triggering the decision making process. So you are telling the policy engine to check your data against this policy, and now after that you will get some decision out of it. So this is how the policy as code works. Now we come back to the main topic. What is OPA? I've been talking about from my first slide. So OPA is Open Policy Agent. We call it in a short form, it is an OPA. It's an open source software. It is managed by Cloud Native Computing Foundation community. It's a well-known community, CNCF, which is helping us in advancing the cloud technology. So they have accepted OPA as an incubation level project in 2019, and after that they graduated OPA in 2021, and it is fully managed by them. So OPA is a general purpose policy engine. When we say general purpose policy engine, it means that OPA is designed to be flexible and adaptable system that can be used to enforce policies in wide variety of contexts and applications. OPA can be embedded as a library. It can be deployed as in daemon, or simply you can run it on the command line. The general purpose nature of OPA allows organization to deploy a single tool for policy enforcement across the cloud native stack, whether it is for the infrastructure, or it could be for application authorization, or it could be Kubernetes admission control. So OPA is the engine that evaluate policy as code written in Rego. So as I mentioned in my agenda, that Rego is the language. So this is the language it uses. I'll explain in my later slide how it works. The other best thing about is um, it decouples the policy decision making from the application. So you have your application code separate and you have policy engine separately. So where you write all your policies. So what it means is that it delivers a decision on whether a resource is compliant with policy. So you don't need to hard code your checks into your application code. So it will have multiple advantages of offloading the policy decision. It provides speed and flexibility to your development lifecycle because you don't need to change application every time. You can just update your policies without having to recompile your application or redeploy your service. And ultimately, that enables you to build at scale, increase visibility into your compliance posture, and enforce policies. How does an open policy agent work? So as I mentioned you that it has three components. So let's dive deep into these three components of policy as code in the OPA policy agent terminology. So in the center of this figure, you are seeing OPA engine, and on the bottom side, you are seeing two icons. On the left, you are seeing policy, and on the right, you are seeing data. So policy is the main core of OPA engine, where you wrote all your standards uh, and rules which you want to follow. And this policy is written in the Rego, as I mentioned. Then you also provide your data. So data should be in the JSON format, or it could be any other structure supported data. So you have your OPA engine, you have your policy in place, and then you have already given the data. Now you have to trigger the process, trigger the decision making process. As I mentioned, you need a service separately, and this service process is already decoupled from the OPA engine. So you will send a request to maybe tell, okay, just OPA, just let me know whether my configuration is compliant or not. So once that process is triggered, your OPA engine will enforce your policies against your data and check it and provide you decision accordingly. And then the decision will be sent back to the service. It could be yes, no. So if it is yes, your configuration is compliant. If no, your configuration is not compliance. Now, as I mentioned, I want to emphasize again that um, uh, OPA accepts arbitrary structured data as input. It could be JSON, YAML, etc. So I hope you understand with this picture that how policy agent works. Let's move forward. Rego. So Rego is a declarative query language from the makers of Open Policy Agent framework. So it has been created by the developers who have created this OPA framework. It's a high-level language in the declarative fashion, and it is very easy to read and write. And uh, it takes the data into structured data in, like I mentioned, in the JSON format, process it, and OPA engine makes the decision on the basis of that data and provide you the output. Now I want to show you a sample policy. How does that policy rule looks like, and how do you provide that input, and what format you get the output. So you're seeing on the left side there is two statements written. So hello is the rule, which is by default false, and you have set the value of message equal to world in the hello rule. Now the hello would be evaluated to true if the message equal to world. So it needs some input, some data, right? You would be providing your input message equal to world. So this input would be evaluated against this policy, right? And when it will be evaluated, the message equal to world would be equal to true. So in the output you will get the true. So this is how you would make a policy decision for all your configuration. So you just need to get your application data in JSON format and provide your input how as an data to the policy engine, and then write your rules how do you want your configuration to be compliant with your standard. Now I want to show you one Rego playground simulation where you can try your Rego policies. So the same policy I put in here, hello equal to false, and then input message equal to world. On the right side, you have the input message equal to world, and then once you evaluate this selection, you will get an output hello equal to true. So this is a simulation environment built by the open policy agent community for you to write and test your policies and play around it. One more thing I want to mention around Rego is that it's a domain agnostic. So you can describe almost any kind of invariant in your policies. For example, which user can access which resources, which subnets ingress traffic is allowed to, which cluster a workload must be deployed to in the Kubernetes, maybe which times of the day the system can be accessed at. So all those things you can define as a policy, and then make it enforce when you check against the policies. Okay. Now let's talk about some of the use cases where you can use policy as code, OPA. So there are multiple use cases, but I want to go through few to make you aware and then use them in your environment. So first and foremost is infrastructure as code provisioning. I made it red because I'm going to give you a small demo later after that. So that's why I'm focusing it. And then when we talk about infrastructure as code, IAC, so you can integrate OPA with most IAC tools. For example, Terraform is one, or it comes with different flavor with different cloud providers. So for example, for AWS, it comes in the form of CloudFormation. So when you integrate OPA with most ISC tools used today to enforce security and compliance policies on infrastructure configuration with the use of CI/CD pipelines, uh, so you can easily incorporate OPA with Terraform to evaluate configuration for specific security configuration, non-compliance items, security vulnerabilities, etc. So the other use case is API authorization. So this for OPA is implementing, for this OPA is kind of implementing the least privilege access for the APIs, microservices, and gateways. When integrated with your data access layer, OPA enables you to define and enforce fine-grained API authorization, ensuring that only authorized accounts can access specific endpoints based on your custom policies. So you can define what APIs are accessible to whom, what level of access they have, read, write, etc. You can write those policies and then evaluate those access requests before reaching it to the end server to access those APIs, whether those are allowed or not. The other use case is Kubernetes admission control. So when we talk about Kubernetes, there is a component comes in which is called as gatekeeper. So OPA gatekeeper is an Kubernetes admission controller webhook that intercepts the request to create, update, or delete Kubernetes resources. So OPA can be integrated with the Kubernetes as an OPA gatekeeper. Then the OPA can then evaluate the request against your policies. The output is the decision to allow or deny that request. So as an OPA gatekeeper, it intercepts all the requests, evaluate the policies against your data, what you want to do, what action you want to perform on Kubernetes, and then provide you decision. Okay, you cannot even access that pod, you cannot make changes on that pod of Kubernetes, etc. The last the last one is compliance and auditing. This is kind of important for the organization who are it can be the organization could be from any industry, so compliance part is always there. So when we talk about compliance, there are different compliance. For example, HIPAA, PCI DSS, NIST would be there coming into picture. So and they would be turning into the controls which you want to deploy in your infrastructure to follow those compliance. And how do you make sure that those controls are applied and working efficiently? So policy as code, again, one of the method which you can use to make sure that you are following that compliance. And further, you can use logs, other methods to audit it and make sure that you are compliant to your frameworks. So these are some of the use cases where you can use OPA. Now, I want to give you a uh, kind of uh, small demo. But before that, I want to provide you some prerequisite. What do you need to, do that, set up that environment in your lab, or maybe in your environment. So I'm going to use the GitHub Actions as a version control system, and then for infrastructure as code tool, I'm going to use Terraform, and for the cloud environment, I'm going to use AWS. So with these three component, I'm going to uh, use my demo. So basically what I did is, uh, so I have shown you one workflow. So on the left side, if you see, I have my Terraform code uh, in my repo, which I want to deploy to the AWS environment, let's say, for example. And then so I have a GitHub Actions workflow, which is a CI/CD pipeline. So once I create my code, I will create a pull request to merge that code to the to the uh, to the main branch, and then once it is there, that workflow would trigger the Terraform plan. So once that Terraform plan is triggered, uh, the changes which I want to deploy would be converting into the JSON format. And once we have the JSON format, as I mentioned you earlier, the OPA policy check would come into picture. So data which we want to change will be evaluated against those OPA policy checks. If all the policies are compliant, if your configuration is compliant with the policies, then you would be allowed to push your configuration to the cloud environment. If not, you need to go back. You will get some message that these are the policies are not allowed or not compliant. You need to make changes in your configuration to make those compliant. And then next section would be Terraform apply in case of Terraform, and it would be different commands for every other cloud provider. And then you can deploy this configuration in your environment. So this is kind of a GitHub Actions workflow, CI/CD pipeline workflow. So let's see OPA in action now. Before diving deep, I want to give you some glimpse of the uh, how does that policy looks like, uh, the practical rules of the OPA. For example, if I go to EC2, EC2 is kind of instance or compute in AWS environment. So it has different rules. So as you see, these rules, kind of uh, coming in different formats. So I'll explain. So every rule has three components here. I'll explain you one by one. Uh, let's see .rego file first. So .rego file is the main file uh, where you wrote your policy logic. So this policy is all about having no public access to the EC2 instance. So which means your EC2 instance cannot have IP address publicly accessible, or public IP address, you can say, as per your company standard. So and here's the logic to evaluate it. So you will evaluate against your configuration changes which you are going to deploy. So here resource is a variable, and input is a special kind of variable which will iterate into your configuration and get that value which you want to check. For example, in our case, it will go to resource changes and resource check the resource mode is equal to managed, and then it will check for resource type is equal to AWS instance. And then here is the main logic comes in, where it will check the particular attribute in that configuration, which is associate public IP address, is not set to false, which means this logic would be comes out true. The policy would deny the configuration changes if you have set associate public IP address equal to true, which means the instance has the public IP address. So this is the logic which you wrote. Now there are two more components when you write the OPA rules. One is the mock data. So when you write your rules, you might not directly test in your production environment. You would need some mock data. So you need to get that mock data and try writing those mocks in different in different take you need to take different scenarios. For example, there is a valid case. In valid case, you don't allow your uh, public IP address to be there, so it's false, which means that configuration is compliant with your standards. It is false here. And then what would be the invalid data? So in invalid file, you would have associate public IP address is set to true. So we need to evaluate our rule against both the uh, uh, mock data as valid or invalid. And then you wrote third file is about the testing it. Then you test these mock data, valid data, invalid data against your policy to verify your policy is working fine. So this is one of the advantage. You just need to have mock data, and then you can write test tools to test your policies. And once your policy is working fine uh, as per the mock data, then you can apply those rules. Now I also want to show you my uh, GitHub Actions workflow, which I have shown you in the slide in a real picture. So basically, you use GitHub Actions as an CI/CD pipeline. So what it does, it have all those actions which a pipeline need to perform to push your code from GitHub repo to the AWS environment. So it uses GitHub runners, which is the environment where it will run all the commands. So if you see here, I have used the Ubuntu latest, which is the default GitHub runner, where all these commands will be running, and then I'll be setting up the Terraform. So I need Terraform to be there, right? Because I'm using Terraform, so the Terraform need to be installed. So it will be installed on the virtual environment set up by GitHub Actions, and then I'll be connecting it with the AWS cloud or any other cloud provider in your case, so that once the configuration is checked, it will be pushed automatically to your cloud environment. Then it will be Terraform validate, which validates, okay, the syntax is fine, the configuration is good, right? And after that, you need to convert that Terraform configuration, which the changes which you want to deploy in your cloud, into a JSON format. So this is very important step, because OPA policy engine understand only JSON. So once you have your data in the JSON format, the next step is to install OPA. So it will install OPA in your virtual environment, and then I have set this repo which has all the OPA policies, as I have shown you one of the example in EC2. So all those policy would be evaluated against the data which you are providing, and it will provide you the result. Now let's see this thing in action. Let me go to my code, and let me show you my sample main.tf file. So this is one sample code which I have wrote for this presentation and explain you. So I'm going to deploy one EC2 machine, and I'm writing a security group. Security group is nothing but it defines what you allow or deny for that particular EC2 instance. I'm not going to actually deploy it into the AWS cloud. It's just for the reference. I'm showing it here, and I will explain you how those OPA policies are evaluated against this configuration. So let's change something here. For example, I'll make edit, and I'm going to change port to 81. So what it says is that it allows any IPs from the internet to connect to this EC2 instance, which I'm going to deploy on these two ports, 8080 and 8081. I'm committing my changes. And then I'll create a pull request. So as I mentioned you that in the flow, which I have shown you in the slide, that whenever I want to make changes, I will have in my dev environment. So once those are ready, I will create a pull request to push those changes into the main branch. And this is the point where this OPA evaluation will take place. Let me show you. So this is this whole process I already have shown you in the GitHub action file, that these are the steps which are which will be executed in the backend when we trigger the pipeline. And this is the pipeline where we add the OPA rules. So if I just go through it, it set up the Terraform as I mentioned you earlier. It connects with you the AWS environment, and then it evaluate your Terraform plan and convert that output into the JSON format. So once you have your JSON format, we install OPA as it is shown here. Then it will evaluate all those policies which has been mentioned in that repo. So we can see all the policies are result as success, which are complying. Let's see if anything is not complying. Okay, there is one rule which is showing as failure. uh, what it says that as per the company standard, as per the EC2 instance, security group should not allow 0.00 as an inbound rule. So this is the company policy that they don't want to allow any traffic from internet. They want to restrict it to particular IP, and that is why that result is fail and evaluation is failed. So you see the scale at which it is working. You define your policies. There could be thousands of rules. You can write it easily. I have shown you the Rego structure. Once you have those policies, you just need to deploy your CloudFormation or your Terraform plan and then evaluate against these policies. So how easy it will be to have your configuration compliant before even it is deployed. So that is why the topic I have mentioned, topic name I have mentioned is shifting left. Shifting left is security. Okay. So now as we have seen that the policy evaluation is failed. Now let's do some changes and making the configuration compliant and try again to see if we pass this time. I'm going back to my configuration, opening the main TF file, going to dev branch. Before that, I just want to merge this pull request just for the ease, and then going back to code and main.tf. Now I'm going to restrict it to a particular IP. Let's say I want to restrict it to a private IP address, which is company's internal IP address, 10.1.1.1/32. I want my application to be accessible only through this IP, and that is what our OPA policies also says, that it need to be restricted. Committing the changes. Going to create the pull request. Okay, we can see that what changes we have done. We have changed 0000 to a specific IP. We are not allowing everything this time. We are just restricting it with a single IP address. Create the pull request. You can just add any comment if you want to. I'm just mentioning testing. Create this pull request. Okay, so it will trigger the pipeline again and evaluate all these rules. So we can just go to actions and see the pipeline is triggered again, and it will do the evaluation process again. It will again go through that pipeline and check those rules again. Let's see. Let it install all those prerequisites. Terraform validate, and then it again generating the JSON format. It is installing OPA, and now have you seen the difference? You see all the policies are allowed. The one which has been failure last time is allowed. So which means your configuration is compliant. You are good to go further to deploy this configuration in your cloud. So you can also automate that process with some other commands here. So by default, once it is allowed or pass the test, it will be deployed automatically. So I've not just put those commands here. I just want to show you the evaluation, OPA evaluation process. This is how OPA works in a pipeline. Now I'm switching back to my slides. We have seen OPA into action already. I've explained you the demo and how OPA is evaluated to deploy your infrastructure code. So I want to give you some references which you can try later and understand more about OPA, and can do the dive deep. So I wrote one Medium blog also on this topic, which you can refer, and follow step by step to implement OPA in your environment. So this is all about today's presentation. In case of any questions, please let me know. Thank you.
Thank you so much, Anshu. It was a wonderful talk. There's so much to learn from you. And I'm checking for the question. There are a few questions in the chat box. You can actually answer them in the chat box itself. And I personally feel that this talk has given me a lot of pointers to think about. And I look forward to meeting you in person, hopefully next year. Thank you so much for joining us today. Have a great day. Thank you and take care.
Thank you.